Hi students, I am Bincy. Welcome to Bincy's class. Today we are going to learn few important numericals from our second chapter, Work, Energy and Power. Before we start the numericals, let us see some important formulae. First formula is for calculating work. Work is equal to F into S and work is equal to Fs cos theta. So we have two formulae to calculate work. When can we use W equals Fs? When force and displacement both are in the same direction, we can use the formula W is equal to Fs. Okay. Now, when direction of force and the displacement are in different direction, that means if there is an angle between direction of force and displacement, we have to use W equal to Fs cos theta. Next formula for work is work done by the force of gravity, that is W equal to mgh. Then we can calculate power. Power using the formula power P is equal to W by T. Okay. Or we can use one more formula to calculate power. Power is equal to Fs by T because W equal to F into S. So we can write F into S by T for calculating power. Now from this formula S by T, that means displacement by time, that is average velocity. So we can replace this S by T by V. So F into V also we can use for calculating power. Okay. Next formula is for calculating potential energy. Potential energy, we use the symbol capital U for that. U is equal to mgh. And kinetic energy K is equal to half mv square. One more formula to calculate kinetic energy related with momentum. Relation between kinetic energy and momentum. This is the formula for that. Momentum is denoted by the letter P. So K is equal to P square by 2m. And we know that momentum formula for momentum is P is equal to mv. Next, one important fact you have to remember in this chapter is maximum potential energy is equal to maximum kinetic energy. That means potential energy at maximum height will be same as maximum kinetic energy when the object is falling just before stopping. What will be its kinetic energy? That will be same as maximum. It will be maximum kinetic energy and it is same as maximum potential energy. At height, when the object is at rest, it will have maximum potential energy. When it is falling down, it will have maximum kinetic energy. Then potential energy will be 0 at that just before stopping the object. Okay. Then we have to learn work energy theorem. What is it? Work done is equal to kinetic energy, final kinetic energy minus initial kinetic energy. Difference in their kinetic energies. W equal to kinetic energy final minus kinetic energy initial, or we can write W equal to half mv square minus half mu square, where v is final velocity and u is initial velocity. These are the formulae you have to learn before starting the numericals. So our first question is, a ball of mass 200 gram falls from a height of 5 meter. What will be its kinetic energy when it just reaches the ground? It is asked in 2011 paper 2-mark question, and given here it is given that G is equal to 9.8 meter per second square. So what we have to find here? What will be its kinetic energy? We have to find kinetic energy, and what all things are given? Given a ball of mass 200 gram. So mass is given, it is 200 gram. So we have to convert this into kilogram. So that is 200 divided by 1000. You will get it as 0.2. Cancel 0, 0. 2 by 10, 0.2 kg. And height is given. Height is equal to 5 meter. One more value is given. G is equal to 9.8 meter per second square. So seeing these things given here, M, H and G, we may think we can easily use U is equal to mgh. But you see here what we have to find is kinetic energy. Kinetic energy formula is half mv square. Okay. Now you see what will be its kinetic energy when it just reaches the ground. Just now I told you when it is just reaching the ground, it has no potential energy and kinetic energy is maximum. So we have to write this statement here. Maximum kinetic energy is equal to maximum potential energy. Then we can use the formula. What is potential energy formula? mgh. Now we can substitute. Mass is 0.2 into G is 9.8. It is given here and H is given as 5. Okay, multiply. When we multiply this 0.2 into 5, we can get as 1. 1 into 9.8, 9.8, and unit is joule for energy. Okay, this is our answer. I told you it is for 2 mark, 1 mark for the substitution, 1 mark for the final answer. So that is how we get the mark. But here, since this is an important statement we have taken, isn't it? If this is not mentioned, that means maximum kinetic energy is equal to maximum potential energy. If we did not mention that statement, we will lose 1 mark for that. That means out of 2, we will get only 1 mark. Okay, so it is important to write this statement and substitution, then the answer also with correct unit. Our next question is, a moving body weighing 400 Newton possesses 500 joule of kinetic energy. Calculate the velocity with which the body is moving. Here also value of G is 10 meter per second square. This question is from 2012 question paper. Again 2 mark question. So first we will write down the given things. A moving body weighing 400 Newton. That means what is given here? Weighing. That means its weight is equal to 400 Newton. Possesses 500 joule of kinetic energy. So we can write kinetic energy is 500 joule. Okay. Calculate the velocity with which the body is moving. And G is equal to 10 meter per second square. We have to find velocity. So we know kinetic energy K is equal to half mv square. So to get V from this, using this equation, we have to know what is mass. So see here weight is given, isn't it? So from weight you can find the mass of the body. How can we find? Weight is equal to mass into acceleration due to gravity. W is equal to mg. From this we can find m is equal to W by G. Okay, m is equal to W by G. So here what is mass? 400 by G value is 10. So we can cancel 0, 0. 40 kg is the mass we got. Fine. Now we substitute. K is how much? 500. So 500 is equal to half into 40 into V square. So we can cancel 2 ones are here, 20 are. Therefore, V square is equal to 500 divided by 20. We can move to LHS, so we get it as divided by 20. Here 0, 0 cancel, we get 25. Therefore, velocity v is equal to square root of 25, which is equal to 5 meter per second. Okay. So, for this substitution, we are getting 1 mark, and for final answer with unit, we get the other mark. Okay. So, it is important here to find mass. Only then we can use that formula. Our next question is, calculate the change in the kinetic energy of a moving body if its velocity is reduced to 1/3 of the initial velocity. This is from 2014 question paper and 2-mark question. So here what is given? Kinetic energy of the body we have to find if its velocity is reduced to 1/3 of the initial velocity. So initially one kinetic energy is there, isn't it? So we consider that as kinetic energy initial or kinetic K1, okay, is equal to half mv square. Initially this is its kinetic energy. Now what happens? Its velocity changed to 1/3 of the initial velocity. So we will take new velocity. So here kinetic energy K1 equal to half mv square. I will write it as v1 square. That is initial velocity. Now new velocity I am taking as v2. v2 is 1/3 of v1. 1/3 of v1. It is reduced to 1/3 of the initial. So what will be new kinetic energy? K2 will be half m v2 square. That is the formula, half m v square. So here it is v2, so v2 square, which is same as half m into v2 is how much? v1 by 3, isn't it? 1 by 3 of v1 means v1 by 3, the whole square, which is same as half m v1 square by 3 square is 9. So we can write this is equal to, we are going to take this part, okay, 1 by 9 into half m v1 square, which is same as 1 by 9. Half m v1 square is what? Initial kinetic energy K1. So new kinetic energy will be K2. K2 is 1 by 9 part of initial kinetic energy. So this is final kinetic energy. Okay. If we have to find the difference, we can write K initial minus K final. So 1 by, okay, I'll write it as K1 minus 1 by 9 K1. So K1 we can take outside, 1 minus 1 by 9, we will get it as, when we take LCM, 8 by 9 we will get 8 by 9 K1 is the change in kinetic energy. This is initial kinetic energy K1, final kinetic energy is 1/9 of K1 and difference is 8 by 9 of K1. Next question is, if the power of a motor is 100 kilowatt, at what speed can it raise a load of 50,000 Newton? So here it is very clear at what speed. So speed we have to find. What all things are given? If the power of a motor is, so power is given, isn't it? Given power is equal to 100 kilowatt. So whenever power is given in kilowatt, first we have to convert into watt. How can you convert into watt? 100 into 1000, because kilowatt to watt into 1000. So you will get it as 1 lakh watt. Next, what speed? So we have to find, can it raise a load of 50,000 Newton? That means what is given here is force. From the unit we can make out. load of 50,000 Newton. Okay, now which formula we can use? We have to think a formula which is related with power, force and velocity. You got it? Power is equal to F into V. Okay, so V will be, V is equal to P by F. Substitute. Power by force is 50,000. We can cancel 4 zeros. 10 by 5 is 2 meter per second. Again here, correct substitution 1 mark. Final answer with correct unit 1 more mark. There are some more numericals from this chapter what we have to discuss. So I will discuss those numericals in my next video. If you find this video useful, please give a like, give a comment and subscribe my channel. Your like, comments and subscription all motivates me a lot. I will come with more helpful videos for you all. Thank you. See you in next video. Bye.